This is problem number 7 from the Chapter 5 closure problems. Create an explicit equation for each recursively defined sequence below. Write out the sequence first to help you write the explicit equation. So A says t of 1 equals 17, which this means the first term is 17. T of n plus 1, so this means the next term, equals t of n, so that's our current term, minus 7. So I'm going to start out by writing some blanks for us to fill in the sequence. So our first term, we'll put our second term. So our first term is what they tell us right here. First term is 17. So we can put 17 for our first term. And next, if we want our next term, we need to take our current term and subtract 7. So 17 minus 7 gives us 10. Okay, we can begin writing our explicit equation. So for this, it starts with t of n equals. And since this is adding, well, it's adding negative 7, this is just like y equals mx plus b. So our m, or slope, or in this case our growth pattern or common difference, is going to be minus 7. So we're going to do negative 7n. And the last thing we need is our zero term. So in order to get our zero term, we have to go backwards. So if we did minus 7 going forwards, in order to go backwards, we need to do the opposite of that, which would be plus 7. So 17 plus 7, we get 24. Since that's positive, we're putting plus 24. So this is our explicit equation. T of n equals negative 7n plus 24. Okay, we're going to start out our next one the same way. T of 1 equals 3, so our first term is 3. And our second term. So this one, next term, so t of n plus 1 is our next term, equals 5 times our current term. So 5 times our current term. 5 times 3 is going to give us our next term, which is 15. So for our explicit equation, we start with t of n. And this one isn't adding, so it's not going to be in the same form as this. We need to do something that's going to be geometric. So for geometric, we're going to start with our zero term. So we're going to have to go backwards. So in order to go forwards, we did times 5. In order to go backwards, we're going to divide by 5. So instead of doing a decimal, I'm just going to keep it as a fraction. I'm going to do 3 over 5, which is the same as 3 divided by 5. So that's our zero term, so we're going to put that first. 3/5. Next comes our multiplier. We're going to put that in parentheses. So what did we multiply every single time going forward? It's the 5. And since we're continuously multiplying by it, we're going to put the n as our exponent. So t of n equals 3/5 times 5 to the n power.